So here we are. Hello everybody, I'm Alessandro. A bit of me, I'm an Android engineer at WeTransfer. WeTransfer is a website where we can send easily files from A to B, and we also try to target creative professionals. So that means we have a suite of tools, and I worked for a long time specifically on Collect, which is a way you can organize your content and share it with other people. So let's start with the actual talk, automating key workflows in your daily developer life. So we're going to go through 3 points mainly, which is we're going to automate the way we create Git tags for each release, and we're going to see why we call this a release. Then we're going to automate the release notes for those releases as well. And then finally, we're going also to automate the formatting of the code, which is something I believe is pretty cool. So yeah, let's start with the first point. Automating the Git tags creation for each release. First of all, we work with Bitrise, but this talk is kind of tool agnostic. So when I do examples, I refer to Bitrise, but I'm pretty sure you can integrate this in any CI. And our CI is like this. We have a daily workflow. A workflow, you can see it as a group of steps in the CI, and you can execute multiple things there. For example, we have a daily workflow where we execute all the tests of the code base. We fetch the latest repository version, etc. And then we check if there are any commits since the last available tag. And if there are any commits, we generate and push a new tag. And we're going to see why in a moment. What did I want to say? No, that's OK. We have only one constraint in this example, and it's the tag format. I mean the tag name. So we want to have the format we have there, which is beta underscore and the number of the beta. This is for this talk, but you can customize it as you like. And you're going to see why in a moment as well. So before diving into the script, we can define a couple of functions. The first one is the get latest tag. The scripts, by the way, are in Bash. I was planning to refactor them in Python, but I never had the time because it's more idiomatic in my opinion. But yeah, this should work fine. So yeah, we have this function called get latest tag, and here what we're doing is just using a simple git command where you can see there is a beta underscore brackets 09 is the format we defined before, so we are filtering all the tags with that format. We are sorting them by creation date, and then we are getting only the latest one. And we are storing the value of this in the latest tag variable. Then we have another function called get latest tag number, and this is simply splitting the variable we defined before with the tag name and getting the number part. So if we have beta underscore 100, you're going to have 100 in the latest tag number variable. So now here we have the script. It's a bit long, but we're going to go through it by steps, and you're going to see it's pretty easy. So first of all, the first step is this one, where we're basically fetching the latest version of the repository, and we're also fetching all the tags. So pretty simple. Then we go to the next chunk, where we can see we're calling the first function we defined, get latest tag. And there we are storing the tag name in the variable, if you remember. And then we are defining another variable here called commits since last tag. In this one, we are simply taking, we're printing the git log since the latest tag to the head of the current repository. Why? Because we want to see if there are any commits since the last tag indeed. Why do we want to do this? Because if you go to the next step, you will see that we are checking. This is a way of checking in Bash if a variable is empty or not. So if this variable is not empty, it means that the git log produced something, and it means there were commits since the last tag. We check this because there are situations like hopefully during the weekend where no one is working, and there are no commits since the latest tag, since the latest release that was released, and so you don't want to execute the script. So in that case, we're going to go through the else, which we're going to see later. So let's stick to the if, and let's go inside. Here we are defining the separator of the format, the tag format. So if you remember, we said we have the format beta underscore and the number. So here there is underscore, and we're splitting the variable, which is stored in the other variable there. And then we are getting the latest tag number, which is one of the two functions we defined earlier. So in this case now, we are storing the number in the latest tag number variable. Once we get that, we also increment that variable, and we print it just for debug purpose. And then finally, we have those two functions, which I'm not showing here, but they're pretty simple. Generate new tag name, it's simply putting back the beta underscore to the new number, and export tag name, it's storing this value into an environment variable. This is because at least in Bitrise, every workflow is independent from each other, and this means that if you want to access a variable that was created in the previous workflow, you need to do something like this. So you see what we did there? We basically took the latest beta, the latest tag for the latest release. We incremented the number only if there were new commits, and then we stored that in a new variable. In case there are no commits, which is the else of the previous if we check it, we are simply making this, this script fail. So now we are creating this, this tag. In case we go through the if, the first block, when there are new commits, we can go through the tag creator script, which is another one. And in this script, we are simply creating a new tag with the new beta tag name we generated, and we are pushing it to GitHub in our case, because that's the hosting solution we use. So yeah, till here it's pretty simple. We actually checked the first mark, so we have a way now to do Git tags automatically, only if there are new commits since the previous one. And what we do here is actually putting also a step in the CI to deliver the build to someone. So we use the internal track in the Play Store, and we deliver those builds to QA. So that's why this is automatic again. So this is pretty cool. Now we can go to the second step, which is automating the release notes for those releases we just created. And for this, we're going to use this GitHub action, which is not done by us, but is available on GitHub for free. And it's called release drafter. And this GitHub action simply keeps a release in a draft state always. So if you are familiar with GitHub, you have the releases page, and there you can see all your tags and releases. So this GitHub action is going to keep a release in a draft state all the time, and it's going to automatically put there the titles of the PRs that are merged. So we're going to use this in order to automate our release notes. We have another of our beloved scripts here, and we can look through it as well. This is also pretty simple. So in the first step, we are defining, we are taking the releases URL for our repository. You can actually hard code this. In this example, it's very simple. I did it for the talk. But in our real implementation, we're actually passing some arguments to this script in order to be able to reuse this script across multiple projects we have in GitHub. So you can pass the, I believe, the owner and the name of the repo, and then you're ready to go and use this in multiple projects, which is pretty cool as well. So again, you define the releases URL. Then we can go to the second step where we are getting, you see, the release ID. There is a release ID variable. Here we're using a CURL command, and what we are doing is simply using an API from GitHub in order to get all the releases. Then you can see in the second line there is a JQ. That's a bash library to parse JSON responses. So we are parsing the JSON response, and we're getting the ID of the release that is in the draft state. You can see that there is a draft equals to true. Because we said before, we're using that GitHub action where we have a release in a draft state. And as far as I know, there can be only one release in draft state all the time, so it's enough to check for that. Then the next step, we're removing the quotes from the release ID, because in the previous step, I'm getting the release ID with the quotes, and I needed to remove that, and that's some bash magic, I guess. So we're doing that. And then finally, in the last step, we are doing another CURL command where we are invoking another GitHub API. So what we're doing here is also quite simple. It's a patch request because we're modifying something. We are using the release ID to modify the release that we just grabbed from the beginning, and we are publishing the release. So if you see the last couple of lines, there is a JSON body there. We are putting the beta tag name, which is the one we generated earlier. And then the important part for us is that there is a draft equals to false there. So that's simply how we publish the release. And the release is not going to stay in the draft state anymore, so it's published. all this leads to this. So thank you to the GitHub action and this script. Now, every time, every day, there are new commits since the previous release. You're going to get something like this. And actually, I want to mention also a couple of things I didn't mention before. So all those things you see there are customizable. So the what's changed header is usually where the default, whenever a PR is merged, the titles are going to get there. You can also put labels in the PRs, and you can define in a GitHub action what do you want to do with those labels. So for example, we have a fixed label, and whenever you put that label, all the PRs that are merged with that label are going to be under the bug fixes header. Another cool thing is that you can do multiple ones. So this is actually real releases we have in our code base. And we have another label called feature. And whenever you merge a PR with a feature label, it's going to be under there. Another cool thing about this GitHub action is that you get that's an hyperlink you can see there. So you get the PR number, and you can see it for history purposes. You can see also the author of the PR. So in my case, in this case, there is one from me and one from my amazing colleague. And then another thing, if you pay attention here, there is the 32, 21, 32, 23, so one is missing. That's on purpose. You can also configure a label for skipping PRs that you don't want to be displayed here. That's useful, for example, if you're updating a simple key and there is no really visible change for the user, and you can just end up with something like this. So that's pretty cool. In the description on the talk, I believe I mentioned that this is for QA purpose. And yeah, I mentioned this because when you merge a PR, usually this is good because it forces you to put meaningful PR titles. But it's also true they are a bit technical, so they are kind of understandable for a QA worker. But it's not the same for a user. So in that case, I think it's still good to go through a manual process. So this is kind of stuff used internally, basically. That's what I'm trying to say. So yeah, we covered the second point as well. So we now know how to deliver releases automatically, and even how to do that with a nice changelog included with them. So yeah, that's pretty cool. And now we can go to the final step of the talk, which is automated code formatting with standard rules automatically applied for the team members of a team indeed. So here, again, we have another tool called Spotless that we use. And this is a tool where you can define formatting rules, and you can easily apply them in the code base. This works with a lot of languages, including Java and others. Here, we're going to go through a simple example for Kotlin, because I guess the most of you are using Kotlin. So first of all, this is the configuration. There is a first step there called ratchet from, and you can see that there is origin main. That's a branch, basically. Why do we do this? If we don't configure this, and we have, let's say, an existing code base, and we install this, we configure this plugin, and then we open a PR, the plugin is going to run through all the files of the PR, of the code base, no matter what. So that means that the first time I open a PR after configuring this plugin, the reviewer is probably going to get a lot of changes and is not going to be happy about that. So if you configure this parameter, you are telling the Spotless tool to apply the script, so to run the script only to the files that changed within the new PR against the branch that is specified there. So if I open a PR today with this configuration, the script is going to be applied only to the files that are changed in that PR. The cons of this is that you are never going to have a fully aligned code base if it's already there. The process that you are going to slowly get there, and the reviewer is not going to get 10 key of lines changed. So that's the first parameter. Then there is the Kotlin block. So here you define a block for each language, basically. So as I said, we're going only through the Kotlin one, and you can define a few simple rules. You can define which linter you want to use, if you want to use any. So it's also another pro of this tool is that it's easy to change the lint on the go. And then you can define a few formatting rules, like indent with tabs. You can also choose to indent with spaces and how many spaces, 2, 4, whatever. You can end a file with a new line, which I believe is the official recommendation from the Kotlin language. And you can include also a license header if you want. The cool thing about this is that it's automatic, so you don't need to go to every coworker and ask them to do this. It's going to be automatically set up, and you're going to see why. Finally, there is also a coding Gradle block, and this is in case you want to use the, in case you use those files and you want to apply some formatting there as well. How do we run this tool? If you want to run it manually, there are two ways. The first one is this, so spotless check, and in this case, the tool is going to run through the files that you changed, and it's going to tell you what is wrong without applying any formatting. The other way is to do directly spotless apply, and this one is going to apply the new formatting automatically without telling you anything. And this is the one we use because, yeah, usually there is not so much to review about the formatting, so we trust the tool more than the humans, I guess. And in order to automate this for all the team members, this is where the magic happens. So we can create a Gradle task that is going to be executed every time we sync the Gradle in our code base. And we use the Git hooks. Git hooks are a way to execute something in relation of some Git command. So in this case, we use the Git precommit hook, which means whatever is in there is going to be executed every time someone commits a file or makes a commit in general. So in this case, we can go through the script that is there. Again, it's a bash script, but this one is very easy. So we're defining that it's a bash script. There is some echo there for debugging purpose again. And then you can see there is the Gradle spotless apply. So the one we defined before in order to execute spotless. And then there is an if there, which is simply checking if the previous command executed successfully. Why do we do this? Because it can happen that sometimes spotless fails for some reason. Happened to us for the first time like a month ago. And in that case, I guess you want to make the CI fail or make the script stop and see what is going on. So in our case, I believe was some issue with the wildcard imports. So that's why we had that issue. And so now what we do is, if the script is successful, then we apply the formatting and we also add those new changes automatically to the commit. Otherwise, we make it fail in the else. And then we're making this file simply executable because that's the one who is going to be executed in the git hook precommit. And you can see there a directory called git /hooks / the precommit file. That's the way to configure a git hook. There are many others. There is a post commit, I believe, and others. You're free to check them out. And finally, this is the result of the spotless configuration. So this is a before and an after. So you know, there is sometimes we put the arguments of a constructor close to the parentheses, and it's like not really aligned. And thanks to spotless, if you commit what is in the before, you're going to end up with this automatically in the after. Another more simple example, but still something that if you pay attention to details, here there is no spacing on the left, there is going to be spacing, proper spacing automatically on the right. And another cool example can be, oops, this one, where someone didn't put the end bracket properly in a new line, and the tool is going to do this automatically for you. So there are other examples I didn't include, but yeah, it's all small things that help you keep the code base aligned properly. And yeah, so we covered also the third point, and this means that I guess we are done. Thank you for listening.